Hi, we have found the average power, which is this in frequency domain for an element. This is the average power. We are going to write this average power in terms of by using new terminology. Why we are using, I'm going to explain all this in this video. So we know we've got a sinusoidal function as a voltage or current. So let's say Vt is Vm cos omega t plus phi. So we know that, on the other hand, that's a sinusoidal function. Let me draw this sinusoidal function here. And change the color. So that's the sinusoidal function here. So this sinusoidal function has got three parameters. One of them is magnitude, the other one frequency here, and that is angle. So this angle is just the moves this signal right hand side or left hand side. It is not critical to measure that parameter if you want to know something about this signal. That frequency is the source frequency. For all the elements we know the frequency in frequency domain for all the elements is the same as the source frequency, so it is also known. What is left is the magnitude. So in practice we would like to know this parameter, and therefore we need to calculate this parameter or measure that parameter. How are we going to measure it? So this is a sinusoidal function. In general, if you want to get some information about this sinusoidal function, you need to find a magnitude of it, or you're going to find the average value of it. If you want to know the average of a signal like that, that is Vt. This average is going to be 0 because this area plus that area gives you 0. This is the period, isn't it? What shall we do? So in order to make it average could be found function, you can get the square of it. When you get the square of it, that's going to be a function like that. It's going to be a positive. There is no any negative value because you get the square of it. When you square it, that means you double this area here. It's not proportional as you see here. So it's going to be a function like that. This is Vt square. So you can get the average of this, no problem with that. So, or another way of saying it, you can find the average of this function, but not this one, because this one is going to give you 0, no information included in that 0. So this, if you calculate this area here, that's blue area. So this area is going to be V square average multiplied with T, isn't it? Capital T. So that is the area here. So if you find this, so you have done this. So when you get the square of it, so this integral gives you this blue area. If you divide this blue area to the period, you're going to get this average. So up to here, that is V square average. So the unit of this is square of the voltage. So if you get the root of it, the unit becomes volt again. So that square root comes from that. So this value is called RMS. Why it is RMS? That is the square, that S comes from that. Mean is this. Root is this, isn't it? Root mean square. So what is this value for a sinusoidal function? So you're going to get this integral here. So this integral is from 0 to t within a period. So v square, if you write this square function here, if you use that trigonometric relation here, it's going to be Vm over 2 cos 2 omega t plus 1 dt. So summation of those two functions, so you can get the integral of each of them separately. Vm 2 cos 2 omega t dt plus 0 t 1 over 2 Vm dt. So that integral here, because of the sinusoidal function, is going to be 0, isn't it? The area underneath that function is 0. So when you come to this one, it's going to be, so the result is Vm over 2 t. So that's this integral here. So that is here. Let me make it a bit different color here. That is here. Is this. So divided by t, that t period t, this disappeared, this disappeared. What is underneath that root is Vm2. So if you take the root of it, you're going to end up with this. Vm square, isn't it? That's, sorry, I made a mistake here. When you get the square of it, so that's going to be square, isn't it? So that is Vm square, Vm square, Vm square. So that is Vm square. So that t disappeared, Vm square over 2 under the root. So if you take it out, you end up with this. So that conclusion tells us that if you measure the RMS value somehow, an equipment measures the RMS value, because why this value? We know that this is an average of a function of which average could be taken. The original function is not like that. So once you measure that value, so then you can say the value of the one of the parameter that you are dealing with. So at the beginning we mentioned that we need to calculate, measure that parameter. One way of measuring it, find the RMS value and multiply it square root of 2. And then you can find the maximum value. So in practice, in our houses, we said we've got independent voltage source of which voltage is 220 volt. That is that RMS value. That is RMS 220 volt. So what is the magnitude, maximum value of it is going to be 220 times 141, isn't it? So if you say it is 150, it's going to be T30, so that means it is in the range of 220 volts. That is the magnitude of it. That is the RMS value of it. So we normally use this RMS value. Why we use this RMS value? Because that is the value that we measure. This is, you need to do a calculation here. So if you apply this result to our average power for an element, so we can write this 2 as square root of 2 of the multiplication. So this gives you the voltage effective value. So that is voltage effective value, which is this. And the other one is current effective value. So these are the values that we measure. So if the circuit is a resistive circuit, that's going to be 0 and that's going to be 1. So our power is going to be P average, V effective, voltage effective and current effective multiplication of those two. So in practical usage of it, if you consider that your TV set at home, let's say it is 220 watts. If you look behind the TV set, you're going to see that the power consumed by this equipment says 220 watts, let's say. So it is in the range, maybe 175, but to make the calculation later on, I assume that 221. If it is so, then that is the power, that's the average power, 220 equal. So V effective, the independent voltage source in our houses is 220 volts effective value. So that effective value, 220. So we can find out effective current that we get out of the energy system is going to be 1 amp. So that means your equipment gets 1 amp current from the source. So you can directly calculate the current that you're going to consume while you are using the TV set at your house. So why explain all that? So you can use all your elements, your equipments that you use in your house, how much current you are consuming, and you can use that in the calculation of power. That also means in the calculation of energy. That means the money that you're going to pay to the supplier. So that's the end of this video. And